Figure 1 shows a rectangle ABCD. The point A lies on the y-axis and the points B and D lie on the x-axis, as shown in Figure 1. Given that the straight line through the points A and B has equation 5y plus 2x equals 10, question A is asking us to show that the straight line through the points A and D has equation 2y minus 5x equals 4. So the first thing we can note is that because we have a rectangle ABCD, we know that each internal angle of this rectangle is 90 degrees. They're all right angles, and this therefore means that the lines AB and AD are perpendicular, which means they cross at 90 degrees. And a general rule for lines on a graph that are perpendicular is that the gradient of one, so in this case the gradient of AB, multiplied by the gradient of AD, should equal -1 all the time. That's a general rule. And because we have the equation for the line AB, which is given to us in the question, we can find the gradient of the line and therefore the gradient of AD. So if the equation of the line is 5y plus 2x equals 10, if we rearrange this to get it in terms of y, because this is what we need to do to find the gradient, if we take away 2x from both sides and then divide through by 5, we're left with y is equal to -2/5 x plus 2. And another general rule for equations of lines is that the gradient is the number multiplied by the x. So the gradient, and we can write this out, the gradient of AB, and we can represent gradient with an m, the gradient of AB is equal to -2/5. And therefore, using our rule that we talked about earlier, the gradient of AB multiplied by the gradient of AD, which is an unknown, is always equal to -1. And therefore, if we divide through by -2/5, the gradient of AD is equal to 5/2. Another thing we can deduce from this graph is the coordinates of the point A, which is another thing we need to determine the equation of the line AD, because we need the coordinates of a point that passes through the line. And we can see that the point A passes through the line AD and the line AB. Now, we're told in the question that the point A lies on the y-axis, and this means that its x-coordinate is 0, and you can see this on the graph too. And therefore, to find the coordinates of A, we need to work out what y is when x is equal to 0. So if the equation of the line is 5y plus 2x equals 10, 5y plus 2 multiplied by 0, which we know is 0, is equal to 10. And therefore, if 5y is equal to 10, y must be equal to 2. And therefore, we can say that the coordinates of A are 0, 2. So A up here is a 2. So now we have the gradient of the line AD and the coordinates of a point that it passes through. And we can use this to determine the equation of the line. So the general formula for the equation of a straight line is that y minus y1 is equal to m multiplied by x minus x1. And in this instance, we can say that using the point A, y1 must be 2, because that's the y coordinate of the point A. The gradient is 5/2, and then x1 is 0, as this is the x coordinate of the point A. So now if we do some rearranging, we're left with y minus 2 is equal to 5/2 x. And therefore, if we multiply both sides by 2, 2y minus 4 is equal to 5x. And you can see if we look back up at the question, they want it in the form 2y minus 5x equals 4. So if we take away 5x from both sides and add 4, we're left with 2y minus 5x is equal to 4, just as the question says. Now, the 4 marks for this question come from both the method marks and the answer marks. So the first mark we get is for finding that the gradient of the line AB is minus 2/5. That's our first mark. Our second mark comes from finding the point A, or more specifically the y coordinate of A being 2. Our third method mark comes from using the perpendicular gradient rule over here and finding that the gradient of AD is therefore 5/2. And finally, we get our answer mark for actually finding the equation of the line AD in the form that the question asked us for. Now part B is asking us to find the area of the rectangle ABCD. And to find the area of any rectangle, we need to find the length and the width and multiply them together. So here, if we say that the length is AB and the width is AD, we just need to find the length of AB and AD and we can find our area. Now, to find the length of AB and AD, we first need to know the coordinates of the points A, B, and D. Now, we already have the coordinates of A, we worked them out in part A, and we have them as 2, 0. Now, for the coordinates of B, we know, and it's shown in the graph and stated in the question, that the points B and D lie on the x-axis. And what this means is that if it lies on the x-axis, its y-coordinate is 0. So, and we also know that the point B lies in the equation 5y plus 2x equals 10. So we can say for point B, at y equals 0, 5y, which is 5 multiplied by 0 and therefore 0, plus 2x equals 10, and therefore x is equal to 5. And the coordinates of B are 5, 0. And we can do the exact same thing for the point D. So at y equals 0, but now we use the equation of the line AD because the point D lies on that line. And the equation for AD is 2y, but as we know y is 0 and therefore 2y is 0, minus 5x is equal to 4, and therefore x is equal to minus 4/5. And so the coordinates of D are minus 4/5, 0. So now we have the coordinates of both of these points. B is at 5, 0 and D is at minus 4/5. We can work out the lengths of both these lines. So the way we work out the length of any line between 2 points on a graph is we use Pythagoras' theorem. And this can be a bit easier to visualize if we were to draw it out. So for the line AB, for example, if A is here at 2, 0, and B is down here at 5, 0, and we draw the line between them, we know that we've gone up by 2 and along by 5. And so to find the length of AB, we would do square root of 2 squared plus 5 squared, which if you put into your calculator is root 29. Now if we use the exact same method for AD, and you could draw out pretty much an identical kind of sketch, we do the same thing for AD. We get that AD is equal to root minus 4/5 squared plus 2 squared. And if we put this into our calculator, it's equal to 2 root 29 over 5. So now we have the width and the length of the rectangle ABCD. And so to work out the area, all we now have to do is multiply the width and the length together. And we are left with 11.6 units squared, because we don't have any units for any of these points. We cannot give a unit, but we're left that the area of ABCD is 11.6. So for the 3 marks available for this question, our first mark comes from using Pythagoras' theorem to find AB or AD. So we can say that our first mark comes from over here. Secondly, we get a method mark for multiplying these two lengths together. And our final mark comes from our answer. It's an answer mark, and we get it simply for writing 11.6 as the area of the rectangle.